Okay, so let's move on to what we call a single replacement reaction. Now, it's less disambiguous what single replacement means, but in general, it's exactly what it sounds like. We just need to model what we mean when we say that. So let's say we have AB, compound AB reacting with C. Now, single replacement means one of these atoms will be replaced or displaced, which is another word, it just means the same thing. Okay, so let's say the cation remains, we kick out B, and then C binds with A. So we have AC plus B, okay? So that's just single replacement. One molecule is replaced, okay? So now let's get into reactions. The balancing rules remain. We are just going through different types of reactions because you might need to identify them, and they have different conventions for balancing them that could make your life a lot easier. So let's say we have aluminum metal mixed with hydrochloric acid, which is very corrosive to aluminum. Sorry, we put aqueous. And then we would get aluminum chloride, remember that's AlCO3 because it's a transition metal. That'd be aqueated, and we would get hydrogen gas. Okay, so this is a little bit more difficult because we have two products going in, or two reactants, sorry, going in, and then two products coming out. So we have a lot more to deal with here. So as per our convention, let's list the atoms. We have one aluminum, one hydrogen, one chlorine, one aluminum, three chlorines, two hydrogens. Now, as always, the odd numbers makes things very difficult to deal with. So let's try and eliminate that odd number first, okay? Or let's work on the hydrogens first because that takes priority, or it makes our life a lot easier. So we put a 2 here because we have two hydrogens here. That will change both the hydrogen and the chlorine, okay? And yeah, okay. The hydrogens are balanced. We know we need to work on the chlorine. So to get that to balance out, what we could do, if you think about it, if you cross these two, so we put 3 here and then 2 here. So 3 times 2, you erase that, we get 6. And then we get 6 hydrogens, 6 chlorines, and then remember 2 here. So you have 2 aluminums and 6 chlorines. And all that we have left is just aluminum. So we multiply that by coefficient 2. And then we have our equation that is, well, one more thing, hydrogen. All right, sorry about that. Well, this equation should be balanced, okay? So let's move on to one more example, and then we will move on to double replacement. Okay, so let's say we took iron 3 chloride, remember iron's in 3 plus state, combine this, iron 3 oxide, combine this with hydrochloric acid, and out comes iron 3 chloride and water. All right, let's make sure that looks good. All right, as per convention, list our atoms. Now we'll just speed up the rest of it. Okay, so let's do one more reaction. So here we have sodium bromide plus chlorine gas yields sodium chloride plus bromine gas. The reason being why this reaction occurs is due to the periodicity of chlorine. Now you can't see the periodic table quite well here, but chlorine is above bromine. It has a higher electronegativity, so it wants that cation more. So as per our convention, let's list our atoms. Okay. All right. So looking at this, since chlorine has a higher periodicity, this is no particular order. Let's just start with chlorine. All right, so put 2 here, changes both sodium and chlorine. But now we need to change sodium on this side. And it just so happens that doing that, bromine also changes to a favorable, or to make the law of conservation of mass true. Thank you guys for watching, and I will see you in the double replacement reaction.